Hi everyone, welcome to the second part of the review for Honors Algebra 2, Quarter 1, Unit 1, Topic 3, SLT 1 through 19. So I'm on number 2, so it deals with inverses. The big important thing about inverses is that we want to go from x to y, and y goes to x. So really we're switching things around. So it says find the inverse of each function, determine if there is a restricted domain that is needed for the inverse to also be a function. Okay, so I'm going to be kind of chatting about that stuff. So first thing, y is equal to 5/3 x squared minus 2. Then I'm going to rewrite them in terms of the other variables switching. So this is going to be x is equal to 5/3 y squared minus 2. So I'm going to bring over the 2. So we get x plus 2 is equal to 5/3 y squared. Multiply both sides by, in a sense, the reciprocal. So that will cancel with that. Multiply this side by 5/3, but you need to make sure that you also multiply the x and also the 2 as well, so that they're both together. So I'm now left with 3/5 parentheses x plus 2, and then is equal to y squared. Now, this is the part where people will start to kind of have different solutions. So when I square root both sides, I need to remember that when I do a square root to both sides, not a cube root, a square root, I need to remember about a plus and minus version. So I'm going to get 3/5 parentheses x plus 2 is equal to y. So that right there is, in a sense, my inverse function. So plus or minus square root of 3/5 parentheses x plus 2. Now, the tricky part here is since this is a plus or minus, that means that it is not a function. That means that you can have multiple x values that stand for, well, you can have one x value that has multiple y values. And that's a big no-no when it comes to, in a sense, when I'm trying to figure out whether something is a function or not. Every x value needs to go to only one y value. And since there's that plus or minus version, right, it kind of messes things up. So the important thing to remember here is there any domain restrictions? So if I was actually thinking about how this graph works, I'm going to show you what the graph looks like. So y equals, so I'm going to write down square root of 3 divided by 5, parentheses x plus 2. So this is my graph right here. But remember, I also have a minus version, so y is equal to negative square root of 3 divided by 5, parentheses x plus 2. And right, see how right here we have that second version right here. So we have the blue and the red. Now we just want the red version. So if I, in a sense, restrict the range from, in a sense, let's only take the top part, so 0 to infinity, the range becomes the domain for the original, so I'm going to restrict the domain from 0 to infinity. So the domain restriction is going to be from 0 to infinity. Now, what does that look like in terms of the original? Well, if I bring back y is equal to, let's do 5 divided by 3, x squared minus 2. So I end up getting this graph. Now, as I talked about in the very first video, I talked about the horizontal line test and the vertical line test. If you do a horizontal line test for this specific function, it does not work, because if I think about how, if I were to put horizontal lines, it would hit the graph twice. So what I'm going to do here is I'm going to restrict the domain. So in a sense, what I'm doing here is I'm just trying to remove the cup, or like, in a sense, one side of the cup. So to do that, Desmos kind of allows me to do this. So I'm going to say I want the values for x to be, in a sense, greater than or equal to 0. And you can see that now it will give me one side of the cup. And in this case, right now, this will end up being a, its inverse will now be a function. So that's where we get the restricted domain. We're really restricting the inverse, the inverse's range, so that it will become a function, which in turn means that the domain will then be restricted. Okay, next one. Y equals 2 parentheses x minus 5 to the third power plus 1. Switch the variables. I'm going to move the minus 1 first. So I'm going to get x minus 1 is equal to 2 parentheses x minus 5 to the third power. Get rid of the 2. But remember, we have to divide everything by 2. So we end up getting, I'm going to move my work over here, x minus 1 over 2 equals y minus 5 to the third power. I'm going to do cube root to both sides, cube root. So I'm now left with the cube root. Remember, we don't do plus and minus for cube roots. X minus 1 over 2 is equal to y minus 5. Then we're going to add 5, and so we end up getting y is equal to, well, I'll just say the inverse function is going to be equal to the cube root of x minus 1 over 2 inside the cube root with a plus 5 on the outside. Domain restrictions, since this is a function, right, there's no plus or minus business, right, we can technically get it to be y equals, there is no domain restriction, so we would say none, because this right here is a function. Over here, letter C, y equals 1/2 square root of x minus 1 minus 7. So x is equal to 1/2 parentheses y minus 1. Why am I doing parentheses there? Square root of y minus 1 and a minus 7. So I'm going to switch, or I already switched the variables. So I'm going to move the 7. So x plus 7 is equal to 1/2 square root of y minus 1. Multiply both sides by 2. Multiply both sides by 2. That cancels with that. So I'm left with 2 parentheses x plus 7. Don't distribute it in because you don't really need to. Y minus 1. Square both sides. Square both sides. Now, you can technically write this as like 4x plus 7 squared, but you don't need to. Just keep it, like, don't simplify anything if you don't have to. So just, you'll have to put in more parentheses, is equal to y minus 1. And then I'm going to add 1, so I'll just write down below. So it'll be 2 inside the parentheses, x plus 7, close parentheses twice, plus 1. Now you can also write that as 4 parentheses, x plus 7, so that the square is only applied to the x plus 7 quantity, and then plus 1. Now you could technically FOIL out the whole like x plus 7 piece, but you don't need to. In fact, you didn't even need to write down the 4 either, but you could if you wanted to. Now this is the interesting part. So this is my normal square root function, right? I'm just going to talk about the parent graph. So it does pass the vertical line test. It does pass the horizontal line test. So that means that its inverse is going to be a function. But if this was the original function and then going to, let's say that is my inverse, its inverse would not be a function because of how the domain restrictions and other things like that happen. Still not sure what that means, because if we think about a square root itself, right, its opposite is something squared, very similar to that first one. So its inverse of a square root function is squared, but there's only one portion that we actually kind of get from this. So which would end up being something like that. We don't actually get the other side when we're doing an inverse. But yet again, you'll be talking about more about that when you get to honors pre-calc. Any restrictions on the domain? There is actually none. No restrictions. Letter D. So when I'm dealing with minus 2 and then minus 3, oh, I'm thinking about trying to graph this. But I already know off the bat, right, this is a parabola, right? Do I need restricted domain so that its inverse is actually going to be a function, right? Because does it pass the horizontal line test? It does not, so which means I'm going to have some type of domain restriction. Now, right off the bat, I can actually kind of tell you where the domain restriction is going to be. So rather than thinking about the domain and the range, and it gets kind of confusing, I can think about just the vertex, right? So the vertex here is actually going to be 2, negative 3, because I'm going 2 units to the right, 3 units down. So this vertex, which would normally be at 0, 0, is going to be 2 units to the right, 3 units down. And actually, when I restrict a domain, I only want the right-hand side. So really, I'm just asking for the x value. So the domain restriction is going to be from 2 to infinity. Pretty simple once you kind of think about structurally what's happening. Okay, y equals parentheses x minus 2 to the second minus 3. X is equal to parentheses y minus 2 to the second power minus 3. X plus 3 is equal to parentheses y minus 2 to the second power. Square root both sides, but don't forget about plus or minus. So I get plus or minus square root of x plus 3 is equal to y minus 2. And then move the 2 over, so the 2 can be written in multiple ways. I can write the 2 in front, so 2 plus or minus square root of x plus 3, or I could write it as y is equal to plus or minus square root of x plus 3, and then tack on a plus 2 on the very end. Either one is acceptable. Okay, so we're going to work on 8a. First thing I'm going to do is I'm going to add 5 to both sides. The 5's cancel. I'm left with 16 is equal to parentheses 3x plus 1 to the 4th power. Now to undo the 4th, or the 4th right here, to the 4th power, we're going to do, in a sense, the 4th root. And we would actually also do a 4th root on the opposite side. Now, something to kind of keep in mind too, if it is a square root, if it's a 4th root, a 6th root, an 8th root, we actually do have also the plus and minus versions. So just kind of off to the side, 16, and if I say the 4th root, that's the same thing as saying 16 to the 1/4. So 16 to the 1/4 is another way of saying what times itself 4 times gives me 16, and in that case that would actually be 2. So we're going to get plus or minus 2 is equal to parentheses 3x plus 1. So I can think about it two different ways. I can think about it as positive 2. So positive 2 is equal to 3x plus 1, and I can think about it as negative 2 is equal to 3x plus 1. So I'm going to subtract 1, I get negative 3 is equal to 3x, divide everything by 3, and so I actually end up getting negative 1 is equal to x. Now the other one, I can subtract 1, I get 1 is equal to 3x, and then divide everything by 3, and so I actually get x is equal to 1/3. Okay, so those are my two solutions right here, but I have to double check each one. So I'm going to check x is equal to negative 1 and x is equal to 1/3. So I'm going to do 11. Does it equal, since 3 times negative 1 plus 1 to the 4th power minus 5? See if that works. And then I also have 11 is equal to, or does it equal to, 3 times 1/3 plus 1 and raised to the 4th power minus 5. Okay, and then from here, I can kind of just work out each one of these. So is this equal to 11? So this gives me negative 3 plus 1, so it gives me negative 2 to the 4th power minus 5. And that's going to end up giving us positive 16 minus 5, which is actually going to give us 11. So that checks. So negative 1 is one solution. And then for the other side, I get 3 times 1/3, which would be 1 plus 1 to the 4th power minus 5. So we actually get 2 to the 4th power minus 5. And that's 16 minus 5, and that actually ends up giving us 11. So both solutions right here, both do a check. So subtract 7. Subtract 7. What time am I at? I'm at 12 minutes. So this is going to be 15 is equal to negative 3 square root of 2x. Let's divide everything by negative 3. So I get negative 5 is equal to square root of 2x. I'm going to square. So I'm going to get 25 is equal to 2x, and then x is going to be equal to 25 over 2. All right, let's see if this actually ends up working out. I'm guessing it probably doesn't, but I never know really once I like try to work out the problem. I think people get scared when they see a fraction. They see like, oh my gosh, I probably screwed something up. But actually it ends up working out pretty nicely, especially when I'm working on these problems. So question mark, does 22 equal 7 minus 3 square root of 2 times 25 over 2? Well, the 2 and the 2 cancel. Then I'm left with 7 minus 3 square root of 25. Then I get 7 minus 3 times 5. And so that's actually going to give me 7 minus 15. And it looks like I get negative 8. Is that equal to 22? Nope. So this is not a real solution, so it's an extraneous solution. Moving on. Am I almost done this page? Yay, almost. I'm going to add 4 to both sides, add 4 to both sides. Those two cancel. I'm left with negative 4 is equal to negative square root of x plus 1. See how they're both negative? I'm actually going to make them both positive. Now I can make them both positive by either multiplying both sides by negative 1 or dividing by negative 1, but really what ends up happening is they actually both go away. So I'm left with 4 is equal to square root of x plus 1. Square both sides, square both sides. So I end up getting 16 is equal to x plus 1. And then I get 15 is equal to x. Double check to see if that works. Negative 8 is equal to, question mark, negative square root 15 plus 1 minus 4. Okay, so looks like I'm going to get negative square root of 16 minus 4. So it looks like I'm going to get negative 4 minus 4. So does that give me negative 8? You bet it does. So that one is a real solution. Go team. All right, next one. Divide by 4. Divide by 4. Get rid of the 4 that's in front. Cube root of x minus 5 is equal to 5. Then to undo a cube root, I'm going to cube both sides. So cubing 5, geez. So that's 5 times 5 times 5. So that's really saying 25 times 5. So what's 5 quarters? $1.25 or 125. X minus 5. And then we end up getting x is equal to 130. Let's double check to see if that works. So we're going to do 4 cube root of 130 minus 5. Is that equal to 20? Now what's interesting here is if you did the math correctly, you'll actually start to see like a lot of different types of patterns or things that just happen. So we're going to do 4 cube root of 125. Well, cube root of 125 is actually just 5. So we're really going to do 4 times 5. Is that equal to 20? And it is equal to 20. So your answer 130 is going to be a valid solution. Should I go on? No, I probably should stop. All right, thank you for watching. This is page 2 of the review session. Apparently, I'm just going to be spending probably a video a page, so that is great. I'll see you later.